For question 2a, look at the power, it's negative, that means we need to put it as a denominator. Simplify in the brackets, and then the 1/3 is the cubed root. Cubed root of 27 is 3, and you divide the power by the 3, it's 9/3, which equals 3 for the power, and there's your answer. For logs, when we subtract logs, we've actually done division of these two numbers. They are divided by. That equals the log of 9 rather. 9 is 3 squared. You could leave your answer like that or write it 2 log 3. Either answer would be correct. Factorize the top of this and write this here as a denominator because it's a negative power. And now you can see the factor of y minus 2 cancels out to give you an answer of y plus 7. So there are some easy achieved questions. Well, read the question. Each side here is x in length, and we know that the whole length down here is 15, and so that we know that this double area is 15 minus x. And we've given that, and that's 2 of those. So let's write out the perimeter for the rope. The 6x are these 6 sides here for the hexagon. The 15 minus x is this length here, and we have 4 of those because the rope is doubled. And then we have 2x minus 4, and it's doubled there as well. Here's 100 meters of rope, so we can put equals 100. Expand the brackets. Simplify your x terms and your numbers on the left. Then solve that equation. And we have x equals 8. And you can go back and check it in the diagram, and you'll find that it comes to 100 meters of rope when x equals 8. So here I've substituted 8 for each x term, and we find that it does equal 100 when you work that out on your calculator probably. Why ever Robert would think about kicking his ball like along this equation here, which is a quadratic, I don't know. But we want the greatest distance along the ground, and we've got here that the distance along the ground would be 0 because this is the height. Just excuse my wife on that one. Now y would have to be 0 because that's the height above the ground. So what value of x makes this bracket 0? X equals 44. So he can kick it along the ground 44 meters. For this question, substitute 3 for the height of the ball, which is this value for y, and then expand the brackets and solve the equation as follows. I'm going to choose to multiply the other side by 121 to get rid of it. Then expand the brackets. Put it all on the left so that it equals 0. And use your calculator to solve the equation. And I made a slight error with the plus here and minus there. So solve that equation. So anywhere between 4.6 meters and 39.4 meters away from the goal would be okay for Robert. For this question, draw a right-angled triangle and label the sides. I'm going to call my shortest side x. So there's my triangle. Now use Pythagoras theory. Expand your brackets. Use FOIL or the cover-up method. Bring everything over to the left-hand side. Change side, change sign. And there we have a nice equation which will factorize easily. Ignore the negative answer. X could equal -3 or +5. We don't have a negative length, so the answer is 5 units. 5 meters in this case. And there's another excellence question. And if you only did F in all of this question too, you would get E7 for the whole question.